The rise of anti-fragile project systems in the traditional world of project management. The highest compliment one could give a system was to call it stable. Schedules were sacred, risks were minimized, and uncertainty was something to be conquered, or better yet, avoided entirely. But in the volatile, hyperconnected, and unpredictable world we manage today, stability has quietly become a liability. The most successful systems are not those that merely withstand stress, they are those that grow because of it. This is where the concept of antifragility enters the stage. Coined by Nassim Nicholas Taleb, it describes systems that don't just survive disorder, they improve through it. Translating this philosophy into project management gives rise to the antifragile project system, an approach that transforms chaos, volatility, and uncertainty into strategic assets. Instead of fearing scope change, stakeholder pressure, or unexpected technical challenges, antifragile project managers see them as opportunities for adaptation, learning, and innovation. Every disruption becomes a data point, every setback, a rehearsal for resilience. These systems evolve not by resisting reality, but by dancing with it, using stress as fuel for continuous growth. In the following exploration, we'll uncover how antifragile principles can be embedded into the DNA of project management, from modular design and optionality to decentralized decision-making and continuous learning loops. The goal isn't to make projects indestructible, but to make them self-improving in the face of disorder. Because in the age of uncertainty, the strongest systems are those that benefit from chaos. 1. Core concept. Antifragility in project systems. Antifragility, a term coined by Nassim Nicholas Taleb, describes systems that don't merely endure shocks, they improve because of them. Unlike robustness, which resists change, antifragility uses change as a catalyst for growth. In project management, this philosophy challenges the very foundation of traditional thinking, the obsession with predictability, control, and rigid planning. An antifragile project system is one that evolves through stressors. Each risk, deviation, or disruption becomes an opportunity to refine methods, validate assumptions, and strengthen response mechanisms. These systems thrive in environments that would break conventional ones. Rather than building elaborate defenses against uncertainty, antifragile systems embrace it, turning volatility into a teacher rather than an enemy. This shift moves project managers from controllers of chaos to curators of evolution. They design adaptive processes, foster optionality, and use failure as fuel for insight. The outcome is not a project that survives volatility, but one that depends on it to improve. 2. Fragile versus robust versus antifragile. To understand antifragile systems, we must contrast them with their weaker cousins. Fragile systems break under pressure. They are over-optimized for a specific condition, lacking flexibility. For example, a software release plan that depends on a single vendor or fixed deadline collapses when unexpected delays arise. Robust systems resist shocks but do not improve from them. They maintain stability, a desirable but ultimately stagnant trait. Antifragile systems, however, gain from shocks. They are designed with buffers, feedback loops, and redundancy that convert errors into knowledge. Think of it this way. A glass vase, fragile, shatters when dropped. A rubber ball, robust, bounces back unchanged. A human muscle, antifragile, when stressed and repaired, grows stronger. In project management, the muscle model is key. Each sprint, crisis, and retrospective strengthens the organization's ability to adapt. Instead of fearing change, antifragile teams build their muscles around it. 3. The nature of volatility. Volatility is the natural language of complex systems. In the traditional PM world, volatility is often labeled as risk, something to neutralize. But in antifragile systems, volatility is data. It reveals weaknesses, stimulates learning, and exposes hidden dependencies. Antifragile project systems treat volatility as a signal, not noise. The goal isn't to suppress it but to interpret it. This perspective transforms uncertainty into a performance-enhancing mechanism. For instance, an agile project that welcomes iterative testing, rapid feedback, and controlled failure is practicing volatility in microdoses. This small stress exposure strengthens the system over time, just as vaccines train the immune system to handle future shocks. 4. Optionality. The DNA of antifragility. Optionality means having multiple pathways to success. In an antifragile project system, optionality is deliberately built into the design. A rigid Gantt chart with zero tolerance for deviation is fragile. But a modular plan with interchangeable options, such as multiple vendors, alternative technical approaches, or flexible resource pools, can pivot easily when disruptions occur. Optionality is not inefficiency, it's strategic readiness. The cost of maintaining extra options is outweighed by the payoff when uncertainty strikes. In practice, project leaders can build optionality through pilot projects, diversified technology stacks, and decentralized decision-making structures. The principle is simple: never rely on a single point of success. Give your project multiple ways to win. 5. Decentralization and empowered teams. Centralized systems often crumble when the unexpected happens because all decision-making is bottlenecked at the top. Antifragile project systems distribute authority and encourage team autonomy. Empowered teams can react faster to local signals, like sudden scope changes, resource shifts, or technical failures, without waiting for hierarchical approval. This distributed intelligence creates an adaptive ecosystem where resilience emerges naturally. In antifragile systems, project managers act as system gardeners, not micromanagers. They cultivate environments where people can make decisions, learn from them, and adjust dynamically. The project thus becomes a living organism rather than a machine. 6. Learning through failure and feedback loops. Failure is often treated as a threat in traditional project environments. But antifragile systems see it as an accelerator of progress. Every misstep, when examined properly, becomes a feedback loop for evolution. Continuous improvement frameworks like Agile retrospectives, Lean's Kaizen philosophy, and DevOps pipelines embody this principle. They turn setbacks into structured learning opportunities. In antifragile systems, feedback is immediate, multidirectional, and action-oriented. The faster the loop, the greater the resilience. Failure doesn't just happen to the system, it happens for the system. 7. Redundancy and slack as strength. In fragile systems, redundancy is seen as waste, something to cut for efficiency. In antifragile systems, redundancy is a form of insurance and flexibility. A project with backup suppliers, secondary workflows, or cross-trained staff is far more adaptable than one stripped bare for cost efficiency. Slack time in schedules and spare capacity in teams create breathing space for innovation when disruption strikes. This principle echoes nature. Animals store fat for scarcity, ecosystems maintain species diversity, and human bodies keep immune reserves. Similarly, antifragile project systems maintain redundancy not to be lazy, but to be ready. 8. Adaptive planning and iterative design. Traditional project planning assumes a predictable future. Antifragile planning assumes the opposite. Instead of rigid master plans, these systems employ iterative design, short cycles of experimentation, validation, and recalibration. Adaptive planning recognizes that forecasts are temporary hypotheses. When new information arrives, the system must adjust without collapse. Agile, Scrum, and hybrid PM models exemplify this adaptability. The antifragile mindset reframes planning as a living conversation with uncertainty. Plans are not sacred documents but evolving maps, constantly redrawn as the terrain changes. 9. Measuring antifragility. You cannot improve what you do not measure. Yet antifragility is not about conventional KPIs like cost variance or schedule adherence. It's about dynamic resilience indicators. These include speed of recovery from disruption, rate of learning after failure, breadth of optionality, how many viable paths exist, frequency of beneficial adaptation, how often stress leads to improvement. Metrics like time to adapt or post-stress performance gain replace static metrics. Measurement becomes not about control, but about system intelligence. 10. Real-world applications. Antifragile project systems have already started transforming industries. Tech startups thrive on fast iteration, pivoting after failure. Each failed feature informs the next innovation. SpaceX applies antifragility by testing, exploding, and improving rockets. Every crash is a data-rich lesson. Healthcare R&D projects apply modular experimentation, learning from micro-failures to accelerate vaccine development. Infrastructure and construction projects adopt digital twins to simulate stress scenarios and evolve design dynamically. In every case, the lesson is consistent. Fragile systems die in chaos. Anti-fragile systems are born from it. Case: Spotify engineering culture. Spotify's tribes and squads model embodies antifragility. Teams operate independently, learn from failures, and share lessons across squads. System thrives under frequent feature experiments and real-time user feedback. The more chaotic the innovation environment, the stronger and faster the adaptation. Case: NASA's SpaceX collaboration. SpaceX missions thrive on iterative test, fail, learn cycles. Rapid prototyping with deliberate risk exposure. Failures are embraced as data-rich learning events. Each explosion makes the next rocket exponentially better. 11. Organizational architecture for antifragility. An antifragile organization is not built through hierarchy but through adaptivity. Its structure resembles a network, not a pyramid. Each node, a team, a unit, or an individual, is capable of independent response and mutual support. Rigid bureaucracies amplify fragility because information flow and decision rights are constrained. Antifragile organizations, however, distribute both intelligence and responsibility. They evolve through modularity, meaning one part can fail without collapsing the whole. For example, in a software enterprise, microservice architectures reflect this principle. Each module operates semi-independently, allowing experimentation, localized repair, and continuous learning. Similarly, project portfolios designed with modular governance can shift priorities rapidly without destabilizing the entire ecosystem. In essence, antifragile architecture values connection over control and learning over linearity. 12. Leadership mindset. From commanders to catalysts, antifragile project leaders abandon the illusion of total control. Instead, they act as catalysts, orchestrators of interaction, feedback, and evolution. Traditional leadership seeks stability. Antifragile leadership seeks transformation through stress. Such leaders welcome volatility as a teacher, not a threat. They don't eliminate uncertainty, they harness it to stimulate growth in people and systems. Their mindset is characterized by curiosity over certainty, constantly questioning assumptions. Experimentation over perfection, preferring progress through iteration. Trust over micromanagement, empowering teams to make real-time choices. An antifragile leader thrives in ambiguity, turns crises into classrooms, and measures success not by control achieved, but by adaptability gained. 13. Antifragile risk management. In traditional models, risk management aims to minimize exposure. In antifragile systems, risk is reframed as a portfolio of potential improvements. The key is not to eliminate all risk, but to balance fragility and opportunity, maintaining exposure to upside volatility while limiting catastrophic downside. Techniques include barbell strategy, combining ultra-safe core operations with high-risk, high-learning experimental zones. Stress inoculation, running chaos drills or simulations to expose system weaknesses under controlled conditions. Dynamic thresholds, recalibrating risk tolerance based on feedback, not static policy. Antifragile risk management doesn't aim for calm seas, it builds better sailors. 14. Continuous experimentation culture. The heartbeat of an antifragile project system is continuous experimentation. Every initiative, no matter how small, becomes a learning probe into uncertainty. This requires a shift from a fail-safe to a safe-to-fail mindset. Instead of designing to avoid mistakes, antifragile teams design to learn from them rapidly. Tools like A/B testing, sandbox environments, and rapid prototyping embody this philosophy. Each experiment feeds the system's intelligence loop, enabling it to adapt in real time. The organizational culture must reward curiosity and celebrate productive failure. Without this psychological safety, antifragility collapses under cultural rigidity. 15. Digital antifragility. Systems that learn digital transformation provides fertile ground for antifragility. Intelligent automation, AI-driven analytics, and adaptive algorithms can transform stress into self-correcting insights. An antifragile digital ecosystem detects anomalies automatically, volatility sensing. Learns from disruptions, machine learning feedback loops. Adjusts workflows dynamically, AI-driven optimization. For instance, predictive analytics can detect project bottlenecks before they escalate, while generative AI tools can replan schedules based on changing constraints. Digital antifragility blends human adaptability with machine precision, a partnership that thrives in complexity. 16. Information flow and feedback networks. Information is the oxygen of antifragility. Poor communication suffocates adaptability. Vibrant information flow fuels it. Antifragile systems build feedback-rich networks where data moves horizontally and vertically with equal freedom. Transparency replaces secrecy, and shared awareness replaces hierarchical gatekeeping. Information feedback must be real-time, enabling immediate sense and respond action. Multi-source, combining team insight, user feedback, and environmental data. Interpretable, transformed into actionable knowledge, not noise. When information circulates dynamically, decisions become decentralized, faster, and smarter, exactly what antifragility demands. 17. Stress testing and evolutionary resilience in antifragile project systems. Stress tests are not performed occasionally, they are continuous. Just as the human immune system stays sharp through regular exposure, antifragile projects strengthen through frequent controlled challenges. These stress tests can include scenario simulations to test decision readiness, load and scalability tests for systems, crisis role-playing sessions for leadership teams. Each test generates new data that reveals where the organization bends, where it breaks, and how it learns. The result is evolutionary resilience, a self-renewing ability to adapt under unpredictable pressure. 18. Governance and antifragile decision-making. Traditional governance emphasizes compliance and predictability. Antifragile governance prioritizes responsiveness and reflection. Decision-making is decentralized but aligned. Teams are granted bounded autonomy, freedom within clear strategic intent. Governance structures shift from command hierarchies to guiding principles and adaptive protocols. Key traits include dynamic approval paths that evolve based on context, governance sprints that review decision effectiveness post-action, empowered review boards that emphasize learning over blame. Antifragile governance doesn't slow decisions down with fear of error, it accelerates learning through intelligent accountability. 19. Human dimension. Psychological antifragility. At the heart of every antifragile system is a human being, and humans, too, can grow stronger through stress when conditions are right. Psychological antifragility involves cultivating resilient mindsets across teams, emotional agility, adaptability, and reflective learning. Leaders can foster this through encouraging ownership instead of compliance, supporting recovery cycles, rest, reflection, recalibration, promoting growth mindset and curiosity over perfectionism. When individuals internalize the antifragile mindset, their response to uncertainty transforms from anxiety to engagement. Teams not only withstand challenges, they actively seek them as opportunities for mastery. 20. Measuring and scaling antifragility across the organization. Scaling antifragility is both an art and a science. It begins with metrics that track learning velocity rather than static success. Organizations can measure antifragility through indicators such as adaptive cycle speed, how fast the system learns from change, cross-functional learning density, how knowledge spreads across teams, stress conversion rate, percentage of disruptions that lead to improvement. Scaling requires consistent reinforcement through leadership modeling, incentives for innovation, and embedded learning loops in every project. Over time, antifragility becomes not just a framework, but a culture. 21. Tools and technologies that enable antifragility. Modern project environments are data-driven, dynamic, and distributed, making technology a core enabler of antifragility. Key enablers include Agile and DevOps toolchains, Jira, Azure DevOps, GitLab, that enable rapid feedback and continuous delivery. AI and predictive analytics that detect volatility early and suggest adaptive responses. Digital twins that simulate project stress scenarios to anticipate failure modes. Knowledge graphs and collaborative platforms, like Notion or Confluence, that preserve learning from past disruptions. These tools act as antifragility amplifiers, enabling organizations to sense, respond, and evolve faster than their environment changes. The focus is not on the tools themselves, but on how they integrate into a living feedback network, transforming data into resilience. 22. Hybrid methodologies and adaptive frameworks. Antifragile systems reject one-size-fits-all methods. Instead, they adopt hybrid frameworks that merge structure with flexibility. A mature antifragile framework might combine Agile's adaptability with Waterfall's clarity for hybrid governance, Lean's efficiency with design thinking's empathy for innovation under uncertainty, PMI's discipline with complexity theory to navigate emergent behavior. These hybrid ecosystems evolve continuously, adapting methodology to the volatility of the environment. The methodology itself becomes alive, a metasystem that learns, unlearns, and reconfigures in real time. 23. Feedback infrastructure and learning ecosystems. Antifragility thrives on rapid and rich feedback. Building an organizational feedback infrastructure means transforming the company into a learning ecosystem. This includes automated performance analytics, real-time dashboards that show what's working and what's failing, learning repositories, databases of case learnings and retrospectives accessible across teams, cross-team reflection cycles, structured knowledge exchanges that allow learning to travel horizontally. The faster and wider feedback circulates, the faster the system evolves. In antifragile systems, feedback is oxygen, and silence is decay. 24. The economics of antifragility. At first glance, antifragility might seem inefficient. Maintaining redundancy, experimentation, and flexibility costs money. But in long-term economic terms, it produces asymmetric gains. Fragile systems aim to minimize cost under stable conditions but collapse under volatility. Antifragile systems invest in learning capital, structures that generate exponential returns when disruption hits. Economically, antifragility creates a positive asymmetry, limited downside, unlimited upside. Projects can fail in small, inexpensive ways, micro failures, but succeed in large, transformative ways, macro gains. The result is risk convexity, a financial architecture designed to profit from unpredictability. 25. Antifragility in Agile and DevOps. Agile and DevOps methodologies are natural vessels for antifragility. Their core principles, iteration, feedback, and continuous delivery, already reflect antifragile DNA. Agile sprints serve as volatility microdoses. Each iteration tests assumptions and reveals system weaknesses early. DevOps pipelines create continuous stress testing of product and process alike. Antifragility amplifies these frameworks by emphasizing learning from noise, not just speed. Instead of aiming for velocity, antifragile Agile focuses on adaptive intelligence, how much smarter the system becomes after each sprint. 26. Case study. SpaceX and iterative failure. Few organizations embody antifragility better than SpaceX. Every failed rocket launch is treated as a data harvest. Instead of concealing failure, SpaceX broadcasts it, studies it, and rapidly integrates lessons into the next iteration. Each explosion accelerates learning, compressing decades of aerospace R&D into years. Their antifragile system combines modular design, localized failure, high feedback velocity, instant telemetry analysis, iterative culture, fail fast, learn faster. SpaceX doesn't aim to avoid chaos, it manufactures controlled chaos as a learning engine. 27. Case study. Netflix and chaos engineering. Netflix pioneered the concept of chaos engineering, an applied form of antifragility. Their system deliberately introduces faults, shutting down random servers, simulating traffic surges, to observe how their infrastructure behaves. This philosophy created the chaos monkey, a tool that breaks systems on purpose. The result? Netflix's infrastructure has evolved to self-heal and reroute traffic dynamically. Instead of fearing outages, the company built a system that learns from simulated disaster. It's a perfect model of antifragility, benefiting from stress through continuous exposure. 28. Antifragile transformation roadmap. Transitioning from fragile to antifragile doesn't happen overnight. It unfolds in stages. Diagnosis. Identify fragility points, where single dependencies or rigid procedures exist. Decentralization. Empower teams and create modular structures. Experimentation. Introduce controlled chaos and safe-to-fail prototypes. Feedback expansion. Build networks to circulate insights instantly. Cultural integration. Reward adaptability and reflective learning. Scaling. Institutionalize antifragile practices across portfolios and departments. Each phase transforms not just process, but philosophy. The organization evolves from seeking stability to seeking evolution. 29. Challenges and paradoxes. Antifragility is powerful, but it comes with paradoxes. Efficiency versus redundancy. Short-term efficiency often conflicts with long-term resilience. Autonomy versus alignment. Decentralization risks chaos if not anchored in shared purpose. Risk appetite. Encouraging experimentation may conflict with compliance-heavy sectors. Cultural resistance. Many organizations fear failure more than stagnation. True antifragility requires navigating these tensions consciously. Leaders must balance freedom with focus, risk with ethics, and experimentation with discipline. It is both a philosophy and a practice in balance. 30. The future of antifragile project systems. As industries evolve toward complexity, antifragility is emerging as the defining capability of 21st century project leadership. Tomorrow's project systems will not be judged by how well they predict the future, but by how well they respond to it. Antifragile organizations will outperform not because they avoid shocks, but because they are built to dance with them. The future project ecosystem will be data fluid, continuously learning and adjusting. Human-centered, empowering creativity under uncertainty. Technologically adaptive, blending AI and human intuition seamlessly. Evolutionary by design, systems that rewrite themselves in real time. In essence, the project manager of the future is not a controller of order, but a navigator of chaos, fluent in the language of volatility, turning stress into strength and crisis into creation. The evolution beyond resilience. The evolution from fragile to antifragile marks a profound shift in how we understand project management, leadership, and organizational intelligence. What began as a search for stability has matured into a philosophy of dynamic adaptability. The antifragile mindset does not resist chaos, it partners with it. Across these 30 sections, we've uncovered how projects can evolve into living systems, capable of learning from disorder, strengthening under pressure, and transforming every obstacle into a growth mechanism. From the core concepts of volatility and optionality to the practical expressions in digital ecosystems, feedback networks, and hybrid frameworks, we've seen how antifragility can redefine what success means in a turbulent world. Traditional project systems aim to survive uncertainty. Antifragile systems aim to harness it. They treat each disruption as an evolutionary pulse, a signal to adapt, reconfigure, and emerge stronger. In a sense, antifragility is not a methodology but a metamorphosis, the transformation of organizations from rigid machines into intelligent organisms. Yet the journey doesn't end here. The next stage, sections 31 through 40, will explore the human heart of antifragility, how communication systems can remain clear amid chaos, how stakeholder relationships evolve when uncertainty becomes constant, how leadership ethics and psychological resilience shape antifragile cultures, and how collective intelligence, the fusion of technology, people, and adaptability, defines the antifragile enterprise of the future. As we move forward, the central truth remains: fragile systems fear change, robust systems endure it, but antifragile systems grow because of it. Antifragility is not just a management theory, it is a living strategy for thriving in a world that refuses to stand still. The question for every project leader, every organization, and every thinker is no longer, how do we survive the next disruption? But rather, how do we build a system that improves because of it?